Hi everyone, today I'm going to be anti-deriving exponential and trig functions. So this is 7.3 from your Year 12 methods textbook, Jacplus. So we looked at anti-deriving just normal sort of things last time in 7.2, and now we apply it to sine and cos. So let's just go back and take a look at deriving. So if we have a y against x graph, and let's say we've got a sine graph, it looks like that. This is y equals sine x. And remember that if we differentiate it, then, oops, let's do it over here. So now let's make it dy over dx, which is of course the gradient. And the first thing that happens is we're going up the hill, so it's a positive gradient. It is going to be a positive cos graph. So our dy dx will equal cos x. And remember also that if it was a 2x here, then it would become 2 cos 2x. And this you could show using the chain rule if you wanted, but really it's best to just know how that works and be able to apply the rule. If we were going from cos, so cos of course looks like this, and that's y equals cos x, and let's again call it cos 2x. And then, well, if we derive that, then that's going down the hill first. It's a negative gradient, so it looks like this. So this would go to dy dx equals negative 2 sine 2x. So the point I guess I'm making is that when we derive, that's how it looks. We go cos to negative sine and we go sine to positive cos. So that means the opposite way, well, cos goes to positive sine, and well, sine goes to negative cos, or negative sine goes to positive cos. So it's going to be the opposite way around. The other thing to note is that, well, if we have sine of 2x and we're going the opposite way, well, then we need to do the opposite, and the opposite would be to divide, not multiply. So it would become cos, half cos of 2x. So for the same reason that if we went this way, well, we'd times by 2. So it would be 1 sine 2x. And that's how we would get to sine 2x. So we divide by whatever's in front of the x, and we apply the negative or positive in the opposite way. Let's go back and do the examples. So find an antiderivative. So when you see the word an, you do not want to put plus c, because the c value could be 0. And well, for the sake of an antiderivative, we assume that it is 0. So let's write it out. The antiderivative of 2 sine 5x plus 3 cos x on 3, or we can say 1/3 x dx, and that's going to equal, we're taking out the fifth, so we're timesing it by a fifth. Sine goes to negative cos, and of course in the brackets stays the same, and then plus 3 divided by, well, actually times, 3, so it's going to be 9. So we're dividing by 1/3, which is timesing by 3, and cos will go to positive sine, and we don't need the plus c for the reasons I already described. So that's it. Quite straightforward. You just have to remember which way to go with the negatives and positives. Now hold on a second, I think I've written a sine there instead of a cos. So the sine will go to cos, of course. It's a bit of a silly mistake there. Okay, let's move down. So now we're looking at the anti-deriving exponentials. So let's remember that if we derive, so if we have y equals e to the x, e is its own derivative, so that means dy over dx would equal e to the x. And if we have y equals e to the 2x, well then what we're essentially doing is taking the derivative of this, which is 2, and multiplying by that. Dy dx would equal 2e to the 2x. So let's think about if we want to go backwards. So anti-deriving, so I can probably leave those arrows there. This is derive, and this is derive. And if we want to go backwards, so anti-derive, so we've got 2e to the 2x. We know that when we anti-derive, we have to get e to the 2x. So it makes sense that when we went the deriving way, this way, that we times by 2. So if we're going backwards, we must be dividing. So that's exactly what we do. We say 2e to the 2x, and we're dividing by 2. So we end up with e to the 2x. So you divide by whatever the derivative up here is. So let's apply that. And we can say, well, x to the 7, that's going to become 1/8 of x to the 8, and then minus 1/3 e to the 3x plus c. And we do need the plus c here because, well, it doesn't say find an antiderivative, so we do need the c. This one, so the same deal. We got 8e to the 2x, and we're just dividing by 2 plus c equals 4e to the 2x plus c. So again, pretty straightforward. Okay, here we have one where we've got e's again, and this is cubed. Now you've got a couple of options here. If you wanted to, you could FOIL it, and your best bet would be to see this as e to the x plus e to the neg x squared, and then times it again by e to the x plus e to the neg x. I know some people don't like using the rule for when we have the 3 here, the cube. But the best option would be to use the rule. So let's do that, and I will write the rule out here, which is a plus b cubed is going to equal a cubed plus 3a squared b plus 3ab squared plus b cubed. So let's sub in the values. So a equals e to the x and b equals e to the neg x. So that means we get dy dx equals, so note the notation here, dy dx, not f dash of x or anything like that, so we want to call it its correct name. So a is e cubed, so e to the x, sorry, so e to the x cubed plus 3a squared, so that's e to the x squared, b e to the neg x, plus 3a is e to the x, b is e to the neg x, and we're squaring that, plus b cubed, and b is e to the neg x. So let's neaten that up, and we're going to get dy dx, remembering that at this stage here, although it takes quite a bit of time and thinking there, that's not anti-deriving it at all. So as I've said in the previous video, you'd be very clever to keep writing this on each line until you actually anti-derive it. You're best to write dy dx, because often people will expand that and then, or whatever the case may be, expand it or put it in a simpler form, whatever, and then they'll forget to do the actual thing they're meant to do. In other words, anti-derive it. So let's see, we're going to get e to the 3x. Oh, my pen isn't working. Plus 3e to the x e to the 2x times e to the neg x plus 3e to the neg 2x times e to the x plus e to the neg 3x. Okay, you might have been able to do that in one go. I've decided to do it in 2 stages here. E to the 3x. And remember, when we multiply indices, we add the indices. So So we've got 2x plus negative x. So that's to the power of x. And then, well, now we've got plus 3, negative 2 plus 1. Again, oops, is negative 1. And then plus e to the negative 3x. And now, well, let's anti-derive it. So we can say y equals, well, divide by 3, 1/3 e to the 3x. So we don't change this 3x, just the same as when we derive. E to the x is its own derivative, so e to the 3x stays e to the 3x. We just take the 1/3 out. Plus 3e to the x, that one doesn't change. Minus 3e to the neg x, and then minus 1/3 e to the neg 3x. And in this case, they're not saying find an antiderivative, so I do need to put a plus c on the end. So this will be my final answer. So this one I think is the last one, and this is another one of those ones where we're solving an antiderivative, or we're finding an antiderivative by recognition or inspection, sometimes they say. So let's ignore, oh no, not that. Let's ignore this for a start and just find dy dx. So that's pretty straightforward. Let's say, well, let u equal x squared. Therefore, y equals e to the u. So I've made this in the power be u, just like you would usually do to do the chain rule. So now we can say dy du is going to be e to the u still, and du dx, so we're looking at this, is going to be 2x. So chain rule, dy dx is going to be, we multiply these two together, so 2e to the x squared x. Okay, so I found dy dx, so that I would get 1 mark for that. Now I hence need to find the antiderivative of x, e to the x squared. So this is that thing where you need to find what's the same and what's different. So we've got an x, there it is, and we've got an e to the x squared, there it is. The thing that we are not wanting there is the 2. So let's see what we can do with that. So I'll take the 2 out, and x e to the x squared. It doesn't matter which way around these goes. I've only changed them because in the question it looks like that. It's in that order. So we know that the antiderivative of this has to be what we started with, e to the x squared. So now I just need to find, well, get rid of what's different. What I want is this part. What I don't want is this. So what I do, I divide by 2 on both sides. And we get the antiderivative of x e to the x squared dx is going to equal half e to the x squared. And you could put it as e to the x squared on 2 if you wanted to. That would be the same thing. All right. And I believe that is the end. And just to be sure, it says an antiderivative. So I wanted to look up, because if it didn't say an antiderivative, if it said the antiderivative or well, the antiderivative, I'd have to put plus c. But because it says an antiderivative, I don't, because, well, the c value could be 0, and that would be an antiderivative. Okay, that completes the worked examples from 7.3.